In lesson number 2, we're going to talk about how scale factor and perimeter and area are all connected. So let's start by looking at two rectangles that are similar. You can see that the scale factor between the small rectangle and the big rectangle is 4 to 8. So the ratio of the sides is simply 4 to 8, which we could reduce to 1 to 2. So we know that the rectangle that's bigger is twice as big as the small one. That's what scale factor means. The perimeter of the small rectangle would be 10 plus 10 plus 4 plus 4, which is 28. And the area would simply be 10 times 4, which is 40. The perimeter of the big triangle would be 20 plus 8 plus 8, which would be 56. And the area would be 20 times 8, which would be 160. So if we compare these perimeters and areas, just like we compared the sides, we can get a feel for the scale factor and the ratio of perimeters and areas. So the perimeter of the small rectangle was 28 compared to the big rectangle, which was 56, which also reduces to 1 over 2, or 1/2. So what I want you to notice is the scale factor is the exact same ratio that the perimeters have. So if we're comparing perimeters of shapes, we can use the same scale factor. But if you look at the areas, the area of the small rectangle was 40, while the area of the big rectangle was 160. Well, that reduces to 1 over 4, which is not the same scale factor. In fact, it's the original scale factor squared. 1 squared would be 1 and 2 squared would be 4. So what a lot of people misunderstand is they think, oh, that rectangle's twice as big, so you have twice as much area. And the answer is no. If the rectangle's twice as big, it's 4 times the area than you started with. Because you not only doubled this length, you also doubled the width. And that's going to create an area of 4 times bigger, because double and double again is 4 times bigger. So that's the main thing I want you to remember. And in the bottom of your notes, you'll see that box. If two polygons are similar, with corresponding lengths in a ratio of A to B, it could be 1 to 2 like we just looked at, 2 to 3, 5 to 7, doesn't really matter. The ratio of their areas is always A squared to B squared, or the square of the scale factor. So in example number 1, we're going to talk strictly the scale factor in areas. If the scale factor between two similar hexagons is 2 to 3, and the area of the smaller one is 220, find the area of the larger one. So I'll sketch this out. You don't really need to do this problem, but just so we can see. So this hexagon is going to have a side of 2, while the slightly bigger hexagon is going to have a side of 3. That's going to give us that scale factor of 2 to 3. So it's not twice as big, it's 2/3 as big. So the scale factor is 2 to 3, but I'm comparing areas. That's the key word. And if I'm comparing areas, I have to square the numerator and denominator and say, well, my areas then are going to be in a ratio of 4 to 9. So now that I know what ratio to compare at, my areas should be 4 to 9. So that would equal the area of the smaller one, which would be 220, compared to what? So now I'm going to solve this equation by simply cross multiplying. 9 times 220 is 1980. And 4 times x is simply 4x. So when I divide that 1980 by 4, I find that that area of the larger one, x, should be 495. And if I compare that, 220 compared to 495, that should be in a ratio of 4 to 9, and it is. That's the whole idea for today's lesson. So let's look at another example. If you look at these two, it says find the ratio of the perimeters and areas of the similar polygons. Okay, first we look at the sides. This is 8 compared to 16. So here's another example where the scale factor is going to be 1/2, or 1 to 2. So the ratio of the perimeters is going to be the same thing. But the ratio of the areas is going to be 1 to 2 squared, which would be 1 to 4. So the big triangle has 4 times the area, it has double the perimeter, and double the lengths of sides. When you do the hexagon, again, let's start with the scale factor. The scale factor, very simple. You're comparing 5 to a side of 7. So the scale factor is 5 over 7. which means the ratio of perimeters, you got it, also 5 over 7. But the area ratios, this is the idea you need to understand, since area is in square units, you have to square that scale factor. So it's 5 squared over 7 squared. So the areas are actually going to be in a ratio of 25 to 49. So area ratio, perimeter ratio. Very simple idea. So we can use that to answer our last example here. A regular octagon has an area of 49 meters squared. Find the scale factor of the octagon to a similar octagon that has an area of 100 meters squared. So area of the small one is 49 meters squared. Area of the big one is 100. So let's just write that down. So the small area is 49, the big area is 100. We know that the scale factor of A to B should be A squared and B squared when I start comparing areas. So if A squared has to be 49, then the ratio has to be 7, and B squared is 100, then B has to be 10. So the original scale factor is 7 over 10 for the sides and the perimeter, but the area ratio is 49 over 100. Very simple idea. Let's see if we can use it on some practice examples.